Okay, so here now, so far we've talked about solving systems of inequalities. Now we're going to move on and look at how we might solve systems of inequalities where with nonlinear inequalities. In other words, one or more of them is not a linear statement, not a linear inequality. So say x plus y is less than or equal to 1, and x minus y squared is greater than minus 5. So this is your system. Now, the key is to be able to sketch these. We do the same thing, except now we've got to think carefully and dig deep and think about how we would sketch x minus y squared is minus 5. And I'm going to rearrange this back out so that I get y, in this case, is equal to x plus 5. Y squared is x plus 5. I moved this over here and I moved this over here. So now y is plus or minus x plus 5, which means that plus 5 over here, remember, means that we shift, okay, this one to the left. So let's sketch this. So y, x, and we know this looks like a square root, but with a point here, with minus 5 being where it ends. So I'm going to, and notice that because this is a y squared situation, both the plus and minus. And because this is where, if you look at how this is going to go, this is going to be y squared is less than x plus 5. So in short, we are expecting to find it to be in the smaller range here, which means inside here. The other one is x plus y is less than or equal to 1. So this one, we're going to find that y is therefore less than or equal to minus x plus 1. So over here, I have 1. Now, I do, and then, okay, noting, of course, that root 5, which is what this point would be, is bigger than 1. And then I have a line that has a negative slope of minus 1. So the line I'm drawing would be like this. And so I have 3 different vertices. This vertex is straightforward. This is minus 5, 0. The second vertex and the third vertex both relate to points where these two intersect. And we know that the region where this is solved is here. So to find the vertices, I have to find the points where these two equations are the same. So x plus y is less than or equal to 1. X minus y squared is greater than minus 5. So let's set these as equalities, because that would be what we would have to do when we find the vertex. So x is 1 minus y. So 1 minus y squared is minus 5. So I'm going to go ahead and move these around. So y squared, move it all to the right hand side, y squared plus y minus 6 is 0. So that's y plus 3, y minus 2 is 0. So therefore our two vertices have y equals to 3 minus 3 and y is 2. Now if y is minus 3, then x is equal to 1 minus y, right? So if that is the case, okay, if that is the case, we would then expect that. So if that's the case, then let me get a pen, proper pen, and erase this back out. Then I would have equals to 1 minus 3, so that would be 4. So at this point, we'll be looking at 4 minus 3. So this one over here is 4 minus 3. The other one over here is y is 2. So if x is 1 minus y, so that's 1 minus 2, so that's minus 1. So x here would be minus 1, and the y is 2. So those would be the vertices of this inequality. It means that we are also going to do another one, which is x squared plus y is going to be less than 2. 3x plus y is less than or equal to 1. So if I'm going to sketch this, then I'm going to start with taking a look at this x squared plus y one. So over here, again, I'm going to draw my axes, x and y, okay? And so this one is y is less than minus x squared plus 2. So over here, I know that this top point is 2, and I have just a good old-fashioned parabola. Over here, with these being minus root 2 and plus root 2. The other one I have over here is y is less than or equal to minus 3x plus 1. So if that's the case, let's see. Y is 1 equals to 1 is the y-intercept. The x-intercept would be, over here would be 1/3. So we are going to end up drawing a line here. Now notice here that both of these involve y being less than. So we are not looking for the region in between. This region would satisfy this one, but not this one. So we actually need this region down here, anything in this region down here, going down to infinity. Let me just draw it out more clearly. So what vertices do we have? We have this one over here, which is 0, 2. And then we have the others that we need to solve for. To do that, I need to solve x squared plus y is equal to 2. And 3x plus y is equal to 1. I need to solve for this. Now, the straightforward way I would think about this, I admit, is as follows. Subtracting one from the other. So, elimination method, if I take 1, this is 2. So 1 minus 2. So that would be x squared minus 3x, my y's cancel out, is 2 minus 1. So that's 1. So this is x squared minus 3x minus 1 is 0. So I'm going to go ahead and use the quadratic formula. So minus b, so that's plus 3 plus or minus b squared, that's 9, minus 4, 1, minus 1, over 2a. So 3 plus or minus square root of 13 over 2. Okay? So that's what you end up with. So this is going to be 3 minus the square root of 13 over 2. And this one, if you have that then, then y is equal to minus 3x plus 1. So that's going to be equal to minus 3 times 3 plus root 13 over 2 plus 1. So over here, that's 3 root 3 minus 9 plus 2, so that's minus 7 over 2. So if you have that, so that's what this one would be. So this is 3 plus root 13 over 2. And over here, this is 3 root 13. Wait. Minus 7 minus 3 root 13 over 2. That's what you'd get over here. And then over here, you can solve it similarly if you want to. Okay?